A handheld metal rod, when rubbed with wool, will neither repel nor attract any object. But if the same rod is held with a wooden handle, it will get electrified provided the metal part is not touched by any part of the body. Let us see a demonstration of the same. Here we have suspended an electrically neutral pith ball with a copper wire attached to a stand. If we connect a negatively charged plastic rod to the other end of the copper wire, the pith ball will attain a negative charge as the charge gets transferred from the rod to the ball via the copper wire. But for the same pith ball, if a nylon wire is used instead of the copper wire, then there is no charge transfer as the nylon wire cannot conduct and the pith ball remains electrically neutral. From these observations, we can now jump to classifying substances based on their ability to conduct. They can be classified into three main categories: conductors, semiconductors, and insulators. Electricity reaches our homes from its site of generation. The electric towers that we see around us transfer this electricity with the help of wires. These wires should be made up of conducting material so as to perform this task. Metals, human and animal bodies, as well as the earth are all conductors. Conductors have free electrons which can move freely through the cross-section of the material. Here we are able to see the electrons move through the conductor. Now that we know what a conductor is, let us understand the charge distribution over a conductor. Here we have a spherical conductor. When another charged substance, a negatively charged rod for example, is brought in contact with the sphere, the charge is transferred to the sphere. It readily gets distributed over the entire surface of the conductor. It does not stay localized to a region of contact. Given here is the trend of increasing conductivity for various substances. Insulators lie right at the bottom of the conductivity scale. They have the lowest conductivity out of the three. This is because they do not allow charges to flow through them so easily. Examples of insulators are wood, glass, and rubber. Semiconductors have conductivity which is higher than that of insulators but not as high as that of the conductors. Common examples of semiconductors are silicon and germanium. Conductors lie at the top of the conductivity scale. Their conductivity is maximum because the charges can easily flow through them. Silver, copper, aluminium, mercury are common examples of conductors. Let us try and understand insulators now. An insulator, also called a dielectric, is a material that resists the flow of electric current. An insulating material has atoms with tightly bonded valence electrons. Here, a sphere, which is an insulator, is placed and a charged rod is brought in contact with it. But we can see that the charge does not get distributed on the surface, as was the case with conductors. An insulator does not permit the free flow of electrons. Subsequently, charge is seldom distributed evenly across the surface of an insulator. The earth is made up of materials that are electrically conductive. A fault current will flow to earth through the live conductor provided it is earthed. All exposed metal parts of an electrical installation or an electrical appliance must be earthed. The main objectives of the earthing are to 1. Provide an alternative path for the fault current to flow so that it does not endanger the user. 2. Ensure that all exposed conductive paths do not reach a dangerous potential. Let us see a demonstration of the same that will also show us the difference between conductors and insulators. When we use nylon or plastic combs to comb our hair, they get electrified. If we take the comb near any metal surface, it will discharge immediately. But if we try to do the same with a metal spoon, it won't get electrified. This is because all the charge from the metal spoon is leaked through our body, which is in contact with the ground. We cannot forget that earth is also a good conductor of electricity. Now let us see how this property of the earth's conductivity is taken advantage of in electrical appliances. Here we are able to see a washing machine. It is connected to three wires. Live, which is the red one, neutral, which is the blue one, and the earth or the green one. The first two, the live and the neutral, carry electric current from the power station, and the third, the green one, is earthed by connecting it to a metal plate buried under the earth's surface. This green wire, the earth wire, is connected to the metal casing of the washing machine through a yellow wire. Hence, any leakage of current to the metal casing is transferred from the metal body to the earth. This goes to the switchboard from where the wires are diverted. When any fault occurs or live wire touches the metal body, the charge flows to the earth without damaging the appliance and without causing any injury to the humans. This would have otherwise been unavoidable since the human body is a conductor of electricity.